Working with fractions. First, we're going to learn how to simplify fractions. When we talk about a fraction is formed by dividing a whole number as parts. So here's an example of a fraction. We have 2 over 3. The bottom number is our denominator. The bottom number is the denominator. The top number is the numerator. And here we have 3 being divided into 2. That bar represents division. And because 3 does not divide into 2, we have a fraction of a whole. The fraction property of 1. When we have an n or some number, integer, other than 0, and we have n being divided by n, or n over n, it equals 1. So you see here we have 2 over 2. Well, 2 divides into 2 once, so we end up equaling 1. And again, the opposite of division is multiplication. So in this case, I could do that denominator, which is 2, multiply it to what we get, which is 1. 2 times 1 equals 2, which is that numerator. So it's the reverse, doing the reverse to find if our solution is correct. Well, the 1 property is basically stating if you divide something into itself, it equals 1. The next n property is any integer can be turned into a fraction by putting it over 1. So every integer can have a denominator of 1. Now, if you are simplifying and you end up with an integer over 1, it will have to be simplified to simply the integer that it is. So n over 1 equals n, or 3 over 1 equals 3. So when we want to simplify fractions, simplifying fractions, you're going to use common factors. And what you're going to do is you're going to divide the numerator and the denominator by the common factors until they no longer have common factors. So whatever you're dividing by the numerator, you have to make sure it's the same number you divide out of the denominator. So when I see 2 even numbers as a fraction, I know that I can simplify by dividing both the numerator and the denominator by 2. So in this case, I divide the numerator and the denominator by 2, and I get a reduced fraction of 16 over 20. Now this isn't in its simplest form, so that means that I'm going to have to keep on dividing out common factors until they no longer have factors in common. So again, they're both even, so I'm going to divide out 2 from each, and I'm going to end up with 8 over 10. And this is still can be simplified, so I'm going to divide 2 out again, and I'm going to end up with 4 over 5. Neither 4 or 5 have common factors, therefore this is my reduced fraction. So if you knew right off the bat that the highest common factor is 8, you could simply do the division of the numerator and the denominator by that highest common factor and have your reduced fraction. So it doesn't matter which method you're using to reduce. What matters is your final answer must be in simplest fraction form. Pause and try. So whether you chose to divide out 2 until there was no other common factors, you would get 2 over 3, or if you knew right off the bat that the highest common factor was 8, you would get the same solution, the reduced fraction of 2 over 3. Pause and try. So in this case, the only common factor is 7. You divide 7 out of the numerator and the denominator, and you get your reduced fraction, 3 over 4. So now, pause and try. When you have this case, and you have a 0 and a 0, common zeros, I like to reduce by simply taking those zeros out right away. And then you have 25 over 55, and the common factor is 5. So your reduced fraction here would be 5 over 11. So when we're talking about adding and subtracting fractions, you're going to need to have a common denominator. So I'm going to teach you a method of how to find the common denominator. First off, you need to understand what prime numbers are. Prime numbers are a number with only two factors, and it's 1 and itself. So a prime number only has two factors, and factors are things that are multiplied together and give you a product. So a prime number only has two factors, 1 and itself. So if I were to do it in numeric order, I would start by 1 is a prime. It's neither a prime or a composite number. 1 is neither a prime or composite. Then I would go to 2. And 2 is only divisible by 1 and itself. Therefore, it's a prime number. Then when you go to 4, you have other factors other than 1 and 4. You also have 2 times 2. So 4 would not be a prime number. 5's a prime number. There's no other numbers besides 1 and itself. 6 is not a prime number because if I had 6 times 1, I could also get 6 by multiplying 2 times 3. So a key note here that I want to notice is any number, any even number other than 2 will not be a prime number. So any even number after 2, it will not be prime because 2 would be able to divide into it. So prime numbers are 1 and itself are factors. So when we're talking about finding the least common multiple or a common denominator, it is the smallest common multiple of the set of 2 or more numbers. So multiples are a product of two numbers multiplied together. So when you want to find the least common multiple, both numbers or all numbers must divide into that common multiple. So let's use this method to find the least common multiple. I like the latter method. It kind of keeps everything together and it uses prime numbers. So when you're looking for the least common multiple for 2 or more numbers, and in this case we're going to do an example of 2 numbers, you're going to take the 2 numbers and you're going to write them in a row. So we have 24 and 36 is going to be our example. And then what you're going to do is you're going to draw the L shape around it. So it's like a half box. So you're taking 24 and 36 and you're drawing that box around it. The next step is to divide out common prime numbers starting with the smallest. So when I'm looking at 24 and 36, I want to think of a common prime number that will divide in evenly into both those numbers. And because they're both even, 2 is a prime number that will divide in evenly. So I'm going to start off by writing 2 on the outside of the box, and then I'm going to divide it into 24 and 36. Whatever is left after I divide it into it, I will write what's left underneath. So 2 goes into 24 12 times, and 2 goes into 36 18 times. And now I'm going to repeat this process until they no longer have common factors. So I'm going to put the L or box around the 12 and the 18, and I'm going to divide out the least common prime number. And again, they're even, so it's going to be 2. So that I divide 2 into 12 and I get 6, and 2 into 18 and I get 9. And I'm going to repeat this process until they no longer have common factors. So 6 and 9 have a common factor of 3, so I'm going to draw that box and I'm going to put 3 on the outside, and I'm going to divide it into the 6, and I'm going to get 2, and I'm going to divide 3 into the 9, and I'm going to get 3. So now 2 and 3 have no more common factors. So now to find the least common multiple from this latter method we created, we're going to take the L shape or the numbers on the outside that create an L, and we're going to multiply them together. So in this case, my least common multiple will be that 2 times 2 times 3 times 2 times 3. Now what I like to do, because it's easier visually to do multiplication, I like to just multiply the side together first. 2 times 2 is 4 times 3 is 12. And then I'll multiply the bottom numbers together. 2 times 3 is 6. And then I'll take the 12 times 6 and I'll have my least common multiple. So I'm showing you how you can do this multiplication without doing it in a row. You can do the numbers on the side multiplied together first, the numbers on the bottom multiplied, and then multiply those two numbers, those two products together. So in this example, my least common multiple will be 72. Pause and try. So again, I'm putting the numbers in a row and putting my little box around it. I'm dividing out common prime factors, starting with the least. Now in this case, 2 doesn't divide into 27 because 27's odd. So the next prime factor would be 3. I divide 3 into 18, I get 6 and 9. And then I'm going to repeat this until they no longer have common factors. So 3 goes into 6 and 9. I'm left with 2 and 3. And I like to multiply the two side numbers together first, the two bottom numbers, and then I'm going to multiply the 9 to the 6. And my least common multiple for 18 and 27 is 54. So both 18 can divide into 54 and 27 can divide into 54. So this would be my least common multiple. So when we're talking about adding fractions, if we have like fractions, you're just simply going to add the numerators. And what makes like fractions is that the denominators are the same. So like fractions, the denominator's the same. When we do addition of fractions, you need the denominator to be the same, and when you add, you leave the denominator alone. So in this case, I have a denominator of 8. When I do the addition here, my denominator is going to be 8, and then I simply add the numerators in this case. So I have 4 plus 5 equals 9. So this addition of fractions, I end up with 9 over 8. And we can leave our answer as an improper fraction, so this would be our solution unless we could reduce. So this is the solution because it will not reduce. So this next example, again, I have like fractions because the denominators are the same. So I can simply, in this case, add my numerators. 3 plus 5 is 8. So it's 8 over 16, that common denominator. And now I can reduce. We have common factors here of 8, so 8 divides into 8 once, and 8 divides into 16 twice. So this fraction reduces to 1/2. This next one, you have a common denominator with a variable in it. As long as the variable is the same letter, it is the common denominator. So you will leave the denominator the same, 10x. And we can add our numerators. So we end up getting 3 plus 7, which is 10, and we have 10 over 10x. Now the number part, the numerical part, can reduce. So we're going to reduce what we can reduce. So 10 divides into 10 once, 10 divides into 10x, x, or 1x. So my simplified fraction here will equal 1 over x. X is in the denominator, so it does not come up. This would be my solution. Pause and try. So we have a common denominator, and remember from previous exercises that when you have the same sign, you're going to add and keep the sign, so we end up with a negative 6 over 8x. Now I can reduce this fraction. They have a common factor of 2, so I'm left with a negative 3 over 4x. Pause and try. So we have like fractions here, and we need to think of that rule. Different signs mean I'm subtracting and keeping the sign of the higher number. negative 10 plus 6. We end up with 4, and because the higher number is 10, we end up with the negative 4 over 12. Now when I'm looking at the fraction here, they have a common factor of 4, so I need to reduce, and it will reduce to a negative 1/3. So adding and subtracting fractions when they're unlike, that means that their denominators are not the same. So when they're not the same, we're going to need to find the least common multiple. So a couple things I want you to check before you start doing the ladder method. First, check if the smallest denominator divides in evenly into the largest, then the largest is my least common multiple. So if I have a denominator of 5 and 10 in my fractions, well, 5 divides into 10, therefore my least common multiple would be 10. So check for that first. And then the next thing you want to check for is if one or both of the denominators are prime numbers, then the least common multiple will be the product, which means if you have a prime number in the denominator and that does not divide in evenly into the other denominator, then the only way we can get a common denominator is to multiply the two denominators together. That would be our least common multiple. Now if we have neither one of these cases, we're going to have to use the ladder method. Once you have your least common multiple, you're going to need to convert your fractions to have that denominator. And when you convert, you're going to be multiplying by a number that's going to get us that common denominator. And you need to multiply the numerator and the denominator by the factor that gets us that least common multiple. So that'll give us the converted fraction. Once you have the fractions converted, you will have like fractions, and then you will add or subtract the numerators. Don't forget, you're always going to need to simplify if the fraction simplifies. So here's an example here. I have 2 over 15 plus 1 over 3. I do not have a common denominator, therefore I cannot add these fractions until I have a common denominator. So that means I'm going to have to convert the fractions. So the first thing I always want you to check is, does the smallest number divide in evenly into the largest denominator? So in this case I see 3 does divide into 15, therefore my least common multiple will be 15. Which means I want my fractions to have a common denominator of 15. And because my first fraction has that denominator, I can just write it down, 2/15 and leave it. The second fraction does not have that denominator of 15, which means I need to convert it by multiplying the numerator and the denominator by the factor that will get me a denominator of 15. So in this case, I need to multiply the numerator and the denominator by 5, because 3 times 5 is 15. So I multiply the numerator, I have 1 times 5, which will give me 5 over 15. Now that I have the converted fractions, I have a common denominator. And because the denominators are the same, I can add the numerators. So now the addition of these two fractions, I end up equaling 7 over 15. And if I could reduce, I would reduce. But in this case, it does not reduce. So that would be my answer. This next example, again, I do not have a common denominator. The denominators aren't the same. So I want to check first, does 3 divide into 7? Always check, does the smallest divide into the larger? And in this case, 3 does not divide into 7. And 3 and 7 are prime numbers. Well, the only way to get the common denominator when the denominators are prime, or one is prime and it doesn't divide into the other, is to multiply the two numbers together. So the least common multiple here for 7 and 3 would be 21. So my common denominator I want to have as 21. So that means I have to convert both fractions to get a common denominator of 21. So the first fraction, I need to multiply 7 by 3 to get 21. So whatever I'm multiplying the denominator by, I have to make sure I multiply the numerator by. So I end up getting 3 times 2, which is 6. So my converted fraction will be 6 over 21. The second fraction, I want a denominator of 21. To get that, I'm multiplying 3 times 7. And whatever I multiply the denominator by, I need to make sure I multiply the numerator by. So I have 1 times 7, which gives me 7 over 21. Now I have my converted fractions. I have a common denominator, so I can add the numerators. And in this case, I end up getting 13 over 21. It will not reduce, so that would be my solution. Pause and try. So in this case, 6 divides into 12, so my common denominator will be 12. The first fraction has that common denominator, so I just bring down the 5 over 12. The second fraction, I need to multiply 6 by 2 to get 12, so make sure you multiply the numerator by that 2 also. 2 times 1 is 2. And now I have like fractions, so I'm going to add the numerators, and I get 7 over 12. Pause and try. So in this case, 6 does not divide into 11, but 11 is a prime number. So the only way to get the common denominator is to multiply 6 to 11. So I get 66. I have to convert both fractions because neither one of them have the denominator of 66. So the first fraction I'm going to multiply by 11, so I get 55 over 66. The second fraction I'm going to multiply by 6 over 6, and I'm going to get 42. Now I have like fractions, so I'm going to add, in this case, the numerators, and I end up getting 97 over 63. Leave it as an improper fraction. This is my solution. Pause and try. So be careful here. 4 divides into 8. 4 divides into 8. Therefore, my least common multiple will be 8. So my common denominator is 8. So the first fraction has the denominator of 8, so I'm just rewriting it. The second fraction, I need to multiply 4 by 2, so I need to make sure I multiply the numerator by 2 also. So I have my converted fraction as 6 over 8. Now be careful here. You see that I have different signs. When you have different signs, you have to subtract and keep the sign of the higher number. So I end up getting a negative 1 over 8. Pause and try. So again, neither one of them will divide into each other. 3 is a prime number. I multiply the two together and I get 12. I need to convert both fractions. I multiply the first fraction by 4 over 4, and I get 4 over 12. And I multiply the second fraction by 3 over 3, and I get 9 over 12. And be careful here, same sign. Same sign means you add and keep the sign, so we end up getting a negative 13 over 12. Leave it as an improper fraction.